This question is about velocity time graphs and also a bit about Newton's laws. So we've got figure 1 shows a girl inside a train. The girl is wearing inline skates. The train is moving at constant velocity and the girl is stationary relative to the train. Okay, so she's moving with the train, but inside, she's still compared to the windows and the seats in the train and so on. And you notice there's an arrow showing the direction of motion of the train or which way the train is going. The girl will be going this way as well. The girl is not touching the train walls. Okay, so between the wheels of the roller skates and her not touching the walls, basically there's no friction that's keeping her connected to the train. So that means the train suddenly decelerates, okay, because there's a force from the brakes of the train, but that force won't act on the girl, okay? So we know this is Newton's first law, and you have to mention it, that things keep moving at the same speed in the same direction unless a force acts on them. So because there's no friction with the girl touching the wheels or gripping the floor with her feet, there is no force on her when the train decelerates. So she will keep moving at the same speed, okay, because there is no resultant force acting on her because of Newton's first law. Then we've got the graph below shows a velocity time graph for the train for part of its journey. So here is our graph, velocity in meters per second, and then you've got time in seconds on here. So write down the equation which links acceleration, change in velocity and time. That is on your equation sheet for 2022 only. Change in velocity divided by time. So between 5 and 11 seconds, so we need to look, 5 is here, okay, and 11 is here. So we need to work out the change in velocity. So at 5 seconds, up here we've got the velocity, so we need to work out our scale. So you've got 2, 3 will be here, and 4 is here. So between 3 and 4, you've got 5 little squares. So that means that each little square is going to be 0.2. Okay, so 3 is here. So the initial velocity is 3.6 at 5 seconds. And we end up at 0 meters per second, 11 seconds. So the change in velocity is equal to 3.6, could say 3.6 minus 0 divided by the time taken between 5 and 11 seconds. That's 11 take away 5 is 6 seconds. So we get 3.6 divided by 6, and that equals 0.6 meters per second squared. You've probably also learned the fact that you find the acceleration from a velocity time graph by finding the gradient. So that is what we've done, because gradient is change in y divided by change in x. So I've looked at the start and the end and the y-axis and I've found the change. I've divided them by the change between where we start looking at on the x-axis and where we finish looking at on the x-axis. Now you might realise that the train is slowing down, so you might put minus 0.6, but that doesn't really matter. So 0.6 meters per second squared. Then we've got part D, determine the total displacement of the train between 0 seconds and 25 seconds. So displacement is the overall distance travelled, including direction. Okay, so we have the train Here we've got positive velocities, which means the train is going forward, slowing down to a stop. But then we go into negative velocities, which means the train is reversing. So you're travelling a distance forward and then you're moving backwards. So total displacement is the overall distance travelled, or your distance from your starting point. So because you're going forwards then backwards, we need to find this distance that they've gone forwards and subtract the distance they've gone backwards. And we do this by using the fact that distance is the area under the velocity time graph. So we've got distance forwards. Okay, so you can see this forwards bit, you've got a triangle and a rectangle. So we'll do the rectangle first. That's got a height of 3.6 and a width of 5 seconds. So the area of a rectangle is just 3.6 times 5. And that's added to the area of this triangle, which has a height of 3.6 and a width of 6 going from 5 to 11. The area of a triangle is half times base times height. So 0.5 is a half, times by 3.6 times 6. Okay, and that will work out at 28.8 metres. So that's 2 marks for that. Then we want to do distance backwards. Okay, so we've got this triangle, and that is going from 16 to 20, so that's got a width of 4. Okay, and it's going from 0 to 1.2, 1.4, 1.5. So we've got half is 0.5 times base is 4 seconds times height is 1.5, and that's added to this rectangle because we're going all the way to 25 seconds, and that has a height of 1.5 and a width of 5. So rectangle is just base times height, so 1.5 times 5, and that equals 10.5 metres. So then we need to do, that's another 2 marks, then we need to do displacement equals 28.8 take away 10.5, and that gives us 18.3 metres. So I'll write my final answer down here, and that was a 5-mark question. Then at a different point in the journey, the train decelerates from a velocity of 40 metres per second to a velocity of 15 metres per second. The deceleration is 2 metres per second squared. Calculate the distance the train travels while decelerating. So we've got a deceleration or acceleration, we're talking about distance, and we've got velocities or speeds. So we need to use the equation, complicated one, v squared minus u squared equals 2 times a times s. Okay, and we're trying to find s, which unhelpfully stands for distance. It says at a different point in the journey, so that means don't take any data off the graph. It's not to do with that anymore. So v squared is final speed, so that in this case is 15 squared. Take away u squared is initial speed or start speed squared, so that's 40 squared equals 2 times acceleration is 2 meters per second, but it's decelerating, so that's minus 2.0 times s, which is the distance what we're trying to find. And the first thing I'm going to do is simplify that. So that will work out as minus 1375 equals minus 4 times S. So the 1375 has come from calculating what that is, and taking the difference. And 2 times 2 gives 4, 2 times minus 4 gives minus 4. If you had these the other way around and you didn't get a minus sign, or you didn't include the minus sign there, just make sure that the distance that you give is positive. Doesn't matter too much. Then we rearrange this. We want S on its own. It's being times by something at the moment, so we need to do a division. So the number on its own on one side of the equals is this one. So minus 1375 divided by minus 4, and that will work out at 343.75 metres. They allow it if you round it or don't, it doesn't matter too much unless they say calculate it to a particular number of significant figures. I probably would round this and give it as 344 personally, or in fact 340 because we've only got 2 significant figures in the question. So that's our distance. I would also recommend going back up here and doing 2 times minus 2 times 343.75 and checking that that's equal to this so that you know you've rearranged it correctly. Again, something you can do at the end of an exam if you've got spare time. Then figure 2 shows part of the track for this train's journey. The train moves at a constant speed along this part of the track and the train is accelerating. Explain how the train can be accelerating while travelling at constant speed. So, because the train is curved, the track is curved, sorry. When the train is up here, it's moving that way, sort of down and off to the right. When it's down here at the bottom, it's moving more straight down. So its direction has changed as it's gone around the train track. Okay. And if you remember, velocity is a change in speed, is a speed in a particular direction. So if it is changing its direction, it is changing its velocity, even though it's speed at constant speed. If you just wrote down the definition of velocity, that would be fine for this mark. Okay, and the final mark is acceleration is rate of change of velocity. Because this is a higher tier level 3 one, they're not giving the mark for just acceleration is a change in velocity. They want the full definition. Acceleration is rate of change of velocity. So 1 mark for your definition of acceleration, rate of change of velocity. 1 mark for recognising that velocity involves direction. Okay, and 3rd mark for the direction is changing, and therefore the acceleration is 2.